Abdur Rahman, you must be thinking that this is not an alcohol. It should have OH group, right?
Yes, sir.
Okay, fine. But there is already an oxygen and there are many hydrogens, right? So OH is there. For example, if I say, what is this? CH4O. You will say, sir, I don't know what is this, sir. But if I write this CH3OH, then you will say, sir, this is methanol. But see, both of these are same thing, na? This is the molecular formula, right? It has no information about the structure of this compound, but CH3OH, it is giving you some idea about the structure of the compound. You got it, Abdur Rahman? Yes or not? Tell me.
Yes.
Okay. Now you tell me, if I want to write the same thing, this molecule C5H12O in the form of CH3OH, so I will write it as C5H11 and OH, right? Both of these are same things, right? Yes or no?
Yes.
I hope now you can make it. So C5,
Yes.
1, 2, 3, 4, 5, and let us say OH in the first carbon. Then we can have OH in the second carbon. We cannot have in the third carbon. So these are the two isomers that we will get if I have. Okay, no, I can have one more here. Okay, so if I have N-pentyl, that means normal pentyl, then I will get these three isomers. But if we can have one more isomers, if I change the, so we have this molecule. Okay, we have this molecule and we have OH here. Okay, so you can see 1, 2, 3, 4, and 5 carbon atoms are there. So 5 carbon atoms and 11 hydrogen will be there and one OH group. Similarly, I can make one more. This is in the first carbon. If I put it in the second carbon OH, and I will get this molecule. I can keep the OH here, and I can also keep the OH here. So these are the isomers that we can make if I have a branch chain. Okay, if I have 1, 2, 3, 4 carbons and then one branch, I can have one more. So we have 1, 2, 3, 4 carbons, and then fifth carbon is here. I can make an OH like this. So this is one of the isomers that I can. Okay. I hope you guys have got the idea. You can try it once more once you start doing the assignment. Abdur Rahman, आपको समझ में आया? Since you have tried it once.
Yes, sir.
Okay, fine. So today, I think we ended with a nomenclature part. So we can start with the. Okay, write the topic. Alcohols are classified as. Number 1, monohydric. Monohydric alcohol contains only one OH group. Second, right? Dihydric. Contains two OH groups. Third is trihydric. Contains three OH group. And fourth is polyhydric. Contains more than three OH group. Okay. So I will give example of monohydric and dihydric and trihydric, which are important. So one of the most important monohydric alcohol is ethanol. Take some examples. Ethanol, or it is also known as ethyl alcohol, or it is also written as ETOH. What is the structure? CH3, CH2, OH. Further, there is another molecule which is known as glycol. Glycol has 2 carbon atoms and both of them have OH group. Okay, similar to this is glycerol. Glycerol is, here we have 2 carbons. Glycerol is a bit bigger name, so 3 carbons. CH2, CH, CH2, all of these are having OH groups. Now, there is another molecule from the class of phenol that we have to remember. Its common name is cresol. So cresols are a group of compounds. These are phenols with one CH3 group. Okay, what is this? Phenol with one CH3 group. Okay, so if you have this is phenol. If you have the CH3 in the ortho position, then it is named as O-cresol. OH. If you have it in the meta position, then it will be named as M-cresol. OH in the para position, it will be named as P-cresol. Okay, similarly, you have to remember a few molecules more. Some dihydric phenols. So if both the OHs group are in the ortho position, it is known as catechol. If we have the OHs group in the meta
Sir, is
position,
it
then it is known as
catechol?
resorcinol. Catechol. CATECHOL.
Excuse me, sir.
Tell me.
So for P-cresol, it should be CH3 on the para side, right? Para
CH3.
position.
Yeah, correct. My bad. So this is resorcinol. If we have the OHs in the para position, it is known as, there are 2 names. The easier name is quinol, or it is also known as hydroquinone. Whenever you start doing some questions on phenol, alcohol, phenols, ether, I will suggest that you go through these cresols and dihydric phenols, catechol, resorcinol, ek baar. Whenever you open the notebook, you start with this. Whenever you open the notebook, you start with this, so that, I mean, you don't pressurize yourself on remembering these things in one setting. You have to perform at the end of this whole class, right? That means at the next year March, you have to give the board examination, or for example, let us say on September you will have your half yearly examination. At that time you have to perform. Okay, so this learning should be stretched a bit. Okay, so what are the things that you have to keep in your mind and you have to retain it? You have to stretch it a bit. आज ऐसा नहीं कि आज याद कर लिया हम, आज तो याद हो जाएगा आपको. But if you will ask yourself without revising after one month, then you will not remember this. Okay, so try it whenever you are starting. जैसे आज क्लास है, then the next class में क्या कीजिए आप? Whenever you are revising, once just go through this O-cresol, M-cresol, P-cresol, catechol, resorcinol, and quinol. Okay, चलिए. I hope all of you have written, right? Yes or no?
So can you read out the last name?
Quinol, hydroquinone, 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 hydroquinone and quinol, quinol. चलें आगे. Can we move forward now?
Yes.
Okay. Now write a note. This is an important note, and this is a conceptual part that you have to remember. More than one OH group, more than one OH group cannot be present on one carbon atom, as the molecule becomes highly unstable. Okay, so for example, if I have a carbon atom with two OH group, one CH3 and one hydrogen, let us suppose that we come across this situation somewhere in our reactions. Okay, so what is going to happen from here? This H2O is going to cleave and you are going to get CH3, carbon with a double bond O, and hydrogen. So we are going to get aldehyde. Now this does not require any reagent. Once you have two OH group on one carbon atom, water is going to leave. Okay. Now if I have, for example, let us say carbon atom, there is OH here, there is another OH here, there is some R and R dash groups. Here also water will leave and we will get R, carbon double bond O, and R dash. That means we will be getting ketones. Now if I have three OH groups, for example, let me have carbon, OH, OH, and OH. Then from here also one H2O will leave. Okay, and we'll be getting R, C double bond O, and OH. Sir, Fahad, R is any alkyl group, no? This is alkyl halide, right, Fahad? RX. R is alkyl group. CH3, CH2. This is one alkyl. This is methyl group. CH3, CH2. This will be ethyl group. समझ में आया फायर?
Yes, sir. Got it.
Okay. Okay. Done everyone? Yes or no? Please tell me. Okay, Sahil. How much should I scroll? Tell me now. कितना scroll करना है?
That's it, sir. This much.
Okay, okay.
Done, sir.
Okay. Now write methods of preparation of alcohol. Write the first method. From haloalkenes. Right here. When haloalkenes are treated with aqueous KOH or NaOH, they form corresponding alcohol. So this is the reaction that we have already seen. If I have RX, alkyl halide, and I treat this with NaOH, and more importantly, aqueous NaOH, then it is going to give me ROH plus KX or NaX. Similarly, if I have CH3CH2Br plus the aqueous KOH, then it is going to give me OH plus KBr. Similarly, you can have I hope these reactions are self-explanatory. There's just one note that we will write. Let me know when you are done.
Done, sir.
Okay. Now, first write a note and write with me. Note. Please write tertiary alcohols are not prepared by using tertiary haloalkanes. By using tertiary haloalkanes, because tertiary haloalkanes Haloalkanes undergo what? They undergo elimination reaction. And give alkenes with alcohol. That means we are going to get a mixture. So for example, if I have carbon and there are 3 CH3 groups like this, and we have a Br group here. Now, obviously there will be, if I use aqueous KOH, right? So we have OH negative, that is my electron rich species. Now, you must know that all these carbons, they are having hydrogens. Now this OH, rather than going and attacking inside this carbon atom, what it does, it easily attacks on this hydrogen atom and it gives some alkene product also. Okay. So see, there are 2 different paths I am making. So one of the OH negative, it is attacking on this carbon atom. And other way would be that it attacks on this one of the hydrogen atoms. Now, if I go through the white arrow, then I will be getting substitution reaction. Okay, I will be getting substitution reaction and CH3, carbon, CH3, OH, and CH3. Br will leave as a good leaving group. And if I use the blue arrow, then I will be getting this product here, CH3, carbon with a double bond, CH2, and then CH3. Now, once we are getting what? Mixture of alcohol and alkene, and then that is why it is not a preferred method of preparation for alcohols. Please remember, whenever you are doing a reaction, when they are asking you to prepare a tertiary alcohol, you will never use haloalkenes. Okay, you are not going to use haloalkene. But if they give you this reaction, then please just make this product, the alcohol. That's it. Don't bother about the alkene. Okay, because alkene will be present, and alkene will be present. That is why we are not making alcohol. We are not using this as a method of preparation. When we ask for a method of preparation, then we want those methods which give us pure alcohols, okay, which do not give me mixture of 2 different things in the same solution. And if both of them are in liquid state, then it is a big difficulty to separate them also. Okay, so for preparation, we will not use tertiary alcohol. But if the reaction of haloalkene is given, then we'll always make with aqueous KOH or NaOH, we are always going to make alcohol only. Is that clear? Yes or no? Please tell me. Depending on the question, you have to change your answers. Got it? Yes or no? Abdurrahman, Abiya, Fahad, and Sahal. Yes or no? Tell me. Aaya samajh mein?
First one we have to do.
There are 2 things. If they're asking you for the preparation of alcohol, they're asking you to make this alcohol. Then, if it is a tertiary alcohol, you are not going to use haloalkane. Itna yaad rakhiye. Okay. Now, another question that they can ask is, they are reacting haloalkane with alcohol. They are having alcohol. They are reacting haloalkane with aqueous KOH. Sorry, they are reacting haloalkane with aqueous KOH or NaOH. Then you are going to form alcohol, no matter what the haloalkane is. But for a preparation of alcohols, you are not going to use haloalkane. Aaya samajh mein, Fahad? Yes or no? Tell me. Got the difference?
Yes.
What is the difference? Tell me. What are the 2 types of question that you are going to be asked, and how will your answers change according to the question? Tell me. First question is for preparation of alcohol. Then,
yes.
Then will you use haloalkane for tertiary alcohol?
We should not use haloalkane.
Yeah, correct. That is one thing. But if they react haloalkane and aqueous KOH, then what are you going to form?
Alkene.
Haloalkane and aqueous KOH, aqueous. So you are always going to form alcohol. Na? Ye wala product aapko banana always. Okay. Fine. Irrespective of what the degree is. Fine. Now they can ask you one direct question, जो कि आपका notes में लिखा हुआ है, why are tertiary alcohol not prepared using tertiary haloalkane? This one question can be asked, so you will be writing the answer here. Okay, you'll be writing as it is, whatever is written here. Okay. Now moving on, the next method of preparation is by reduction of aldehyde and ketones. We're using blue, yeah. Reduction of aldehyde and ketones. Please write with me. Aldehydes and ketones can be easily converted to alcohols using the following reducing agents. Okay, following reducing agent. What are the reducing agent? Number one, please write H2 in the presence of. Okay, so it will be shown like this: H2 in the presence of nickel or PT or PD. Okay, so this is also known as catalytic hydrogenation. Catalytic hydrogenation. So we have a catalyst, nickel, PT or PD. So in the reaction, you will be given like this: H2 upon nickel above the arrow. Okay, so this is how you're going to see the reagent. Next one is lithium aluminum hydride, LiAlH4. Lithium aluminum hydride. Third is NaBH4. Sodium borohydride. Then write the last one. Just a second. Yes, sodium in the presence of ethanol. Okay, so C2H5 OH. Sodium in the presence of ethanol. Then all of you, yes or no, please tell me. All of you wrote the 4 reagents. No, लिखिए जल्दी लिखिए, बताइए फिर, है ना? Okay, I think guys are done. Okay, now please see the 2 reactions that I am writing. Okay, see the 2 reactions that I'm writing. If you have an aldehyde, okay, so when you have aldehyde forms primary alcohol, primary alcohols. Okay, so if I have R, carbon, double bond O, and what is aldehyde? Aldehyde will have 1 hydrogen attached to that carbon atom. When I use any one of those reducing agent, okay, what agent? Reducing agent. Any one of these, H2 in the presence of nickel, PD, LiLH4, NaBH4, or sodium and ethanol, then this oxygen is going to get one hydrogen. This pi bond will break. Okay. This carbon is also going to get one hydrogen. So this pi bond will break, and you are going to get hydrogen and hydrogen. Just okay. So in once we add reducing agent, I will be getting R. Carbon. This carbon is going to get hydrogen, and one more hydrogen is there, so it will already get hydrogen here. Now this we have OH. Right, next ketones give or ketones form. Secondary alcohols. R, carbon double bond O, R dash. The presence of reducing agent. We are going to get again, this oxygen is also going to get hydrogen. This carbon is also going to get hydrogen. So we'll be getting R, CH, R dash, and this carbon is going to get OH. All of you done? Yes or no? Please tell me. Done, everyone?
Sir, in the first one, why O is not attached to the carbon?
What is not attached? What is not attached?
Okay. It comes down.
Got it?
Okay.
It comes down नहीं है वो मतलब लिखने का तरीका है. It doesn't come down. That's how I chose to write it. I can write it like this also. It is not a different molecule. Please remember this. If I write it like this, it is my choice. Okay. It is not a different molecule. Both of these molecules are same only. Got it, Fahad? Yeah. Okay. Let's move on. So for example, you have CHO, aldehyde in the presence of, let us say, NaBH4. Then this aldehyde is going to get converted into what? This carbon atom. And this carbon atom is going to get CH2OH. CHO becomes CH2OH. Okay. Similarly, if you have, let us say, CHO like this, LiLH4, all things are as it is, and you are going to get CH2OH here. If I have a ketonic group in the presence of H2 in the presence of nickel, let us say, this ketonic group is going to get converted into OH as it is. Okay? Chali, write some reactions. Abdurrahman, can you please turn the mic on?
Yes, sir.
देखिए इस कार्बन को हाइड्रोजन मिलेगा, हमने पहले ही कहा था ना, नहीं कहा था हमने, कहा था हाइड्रोजन मिलेगा, है ना? ये सब अब्दुल टेल मी. हाँ, राइट. तो ये CH था, CH2 हो गया, एक हाइड्रोजन मिला, तो ऑक्सीजन को हाइड्रोजन मिला, तो ये OH हो गया. Got it? Yes or no?
Yes.
Okay. Send the answers on WhatsApp, okay? Giving you guys 5 minutes. Please send your answers on WhatsApp.
So can you scroll up?
Scroll up, okay. Enough?
Yes, sir.
Look at the patterns, okay? You guys have 3 more minutes, okay? Send the answers on WhatsApp. Okay, I've got from Fahad. Yeah, Fahad, correct. Very good. Very good, very good. Keep the concepts in your head and start looking at patterns, okay? Okay, who has sent me answers? Abdur Rahman. Okay, correct, and correct. Very good. Fine. Waiting for others. Oh, only Sahel is here. You're seeing Abhiya is getting disconnected too much today.
I've sent it, sir.
हाँ Sahel मिल गया आपका. Correct, and correct. Very good. Okay. So whenever you have to make a 1 degree or 2 degree alcohol, then you'll be thinking of this aldehyde and ketones. Okay. So this molecule will be CH2OH. This will be OH. This will be OH. Make sure you know what is happening behind the scenes also, okay? You just don't start looking at patterns and copying the things. And try to understand also what is happening inside. But when you are writing the product, then your mind should not even think about writing the product. No, it should be in your muscle memory. But when somebody asks what is happening, then you will say, yes, reduction is happening, and reduction means the addition of hydrogen atoms. That is why one hydrogen is getting added on the carbon atom, one hydrogen is getting added on the oxygen atom. In this case, also one hydrogen is getting added in this oxygen and the other hydrogen is getting added in the carbon. Since in the bond line structure we don't show the hydrogen, that is why that is not visible. But in the reduction, see, this is very important. Note this down. In reduction of aldehyde and ketones, what happens? In reduction of aldehyde and ketones, what happens? We have the C double bond C, C double bond O. In this, the pi bond breaks. And there are bonds which are formed. What are the bonds formed? You have carbon and hydrogen bond, which is formed. And oxygen and hydrogen bond is formed. Okay. So C double bond O is the C double bond O does not break. Okay. C double bond O may say pi bond breaks. Okay. And then the carbon atom is getting hydrogen and the oxygen atom is getting hydrogen. Chaliye. Right, next, one more point. Note. Tertiary alcohols cannot be prepared by reduction of aldehyde and ketones. Right, next. By reduction of carboxylic acid and esters.
So the last point was by reduction of alcohol. Okay, aldehyde.
Aldehyde and ketones. Tertiary alcohols cannot be prepared by reduction of aldehyde and ketones. Okay, right, next. By reduction of carboxylic acid and esters. Right here. Carboxylic acids are reduced to primary alcohols primary alcohols using strong reducing agent just right, because I don't think you need any more reagent than LiLH4. Strong reducing agent LiAlH4, lithium aluminium hydride. Okay, lithium aluminium hydride. So if I have R, C double bond O, OH, then two things happens here. Two things happen. First of all, I will react this with LiLH4. And the second step, I will be adding water. Generally, water is added whenever you have alcohol to get not get salts. When you add water, you will get complete pure alcohols. Okay. So when we have carboxylic acid, we get R CH2 OH. Okay. So this oxygen is gone because reduction means removal of oxygen or addition of hydrogen. So both the things are happening here. This carbon atom, it is removing the oxygen and it is also getting what? It is also getting hydrogen atoms. Okay. So right. Some more examples. As simple as that. Okay, COOH, it gets converted to CH2OH. So this carbon atom, it will get converted to CH2OH. Okay, or rather than writing this, what you can do also, just remove the oxygen. OH. If you have COOH, same reagents, everything will be as it is. This will become CH2OH. That's it.
So, sir, the LiH would be reducing agent.
It is a reducing agent, correct?
So, only that reducing agent can be used.
Yeah. Only LiLH4, nothing else. Okay. So if you have something like this, also give that example. Okay. So see, here we are having this is a ketonic group. This is the carboxylic acid group. Okay. And in the reagent, if I have NaBH4, so NaBH4 can reduce ketone, but it cannot reduce carboxylic acid. So this carboxylic acid will be as it is. This ketone will get converted to OH. Done, everyone? Yes or no? Please tell me.
Yes, sir.
Okay. Now let us look at esters. Right, esters. Esters give a mixture of two alcohol. Two alcohols on reduction. Okay. So let us see. What is an ester? Ester is R, C double bond O, and oxygen. So till here it is very similar to what? Very similar to the carboxylic acid. But after this O, we don't have H, we have another alkyl group R dash. Okay, another alkyl group R dash. Now, if I treat this with any reagent, and not any reagent rather, we can use two reagents here. In your NCERT, you will be only shown LiAlH4, but we can also use sodium in the presence of ethanol. Okay, sodium in the presence of ethanol. But our primary reagent will be for ester LiLH4. Now what happens here? Please see. This C single bond O, it breaks. Okay, C single bond O breaks. And this carbon atom it gets one hydrogen here, and this also gets one hydrogen here. So we are making R. Let me write this product in the product from this fragment in blue. I will write the product from this fragment in green. So from the blue one, you are going to get R, CH2, OH, plus from the green compartment, from the green area, we are going to get R dash OH. Okay, R dash OH. Okay, please write this down and try to make the molecules. Write these two products. लिख लिया आप लोगों ने product? Did you guys write the product? Abdurrahman, Fahad, and Sahal?
Yes, sir.
Yeah, okay. I think somebody sent me also. Okay, Abdurrahman has sent me. Abdurrahman, आप bonds तो बनाया कीजिए ना. Bonds नहीं बनाएगा तो कैसे पता चलेगा? Your bonds are very small. Okay. So here I am going to make this two CH3 CH2 OH plus I will be getting CH3 OH. Right? Now in the third question, देखिए यहाँ पे आपने बहुत गलती की है. ये bond तो आपने ठीक break किया है. But this molecule will be what? Will have OH here, no? That is it. Right? There is no other carbon. You have just two carbons here. How many carbons are we having? Just a sec. How many carbons are we having here? We are having two carbon atoms. So this will be what? CH3, CH2OH plus. Here also we are having two carbon atoms. So this will be also CH3, CH2OH. Okay.
Yes.
Okay. So
should we draw it or can we do it with a bond line?
Bond line also. No problem. There's no difference. I'm just showing मतलब exactly क्या चल रहा है. ये आपको क्या हो जाता है? OH plus OH. That's it. Now write the next one, which is very, very, very important. Please write by using Grignard reagent. Fourth one. Okay, using Grignard reagent. So please see here. Then first of all, we will try to make the products. ठीक है, product बनाना आना चाहिए. Then we will understand what is going underneath. ठीक है, अंदर क्या चल रहा है. See, by using Grignard reagent. So with Grignard reagent, we also use one more thing, which is a aldehyde or a ketone. So aldehyde and ketones, they have C double bond O, both of them. Please listen and don't write anything. Okay, please don't write anything. Both of them will have C double bond O. There will be two groups attached on this carbon atom, right? Two groups attached on this carbon atom. Plus, I will use an RMGX. RMGX is my Grignard reagent. Okay, RMGX. Now, in the first step, what is going to happen? This R group will be having delta negative because Mg is metal. Metal has a tendency to lose electron. It will give electrons to R. It will be delta negative. This carbon atom, rather here, carbon atom is delta positive because it is bonded to a electronegative atom by a double bond. Now this R group is going to attack on this carbon atom like this, and this pi bond is going to break like this. And because carbon cannot have how many bonds? It cannot have more than 4 bonds. Now please see this R group is getting attached to the carbon atom. Okay, so first of all, I will make this carbon as it is. Okay, carbon as it is. Now what has happened? The pi bond has broken, so we have oxygen here, and this carbon is getting the R group of Grignard reagent, and we are getting MgX from here. MgX also from the Grignard reagent. MgX. Okay, all of you got it? Yes or no, please tell.
So what is the reagent here?
The reagent is RMGX, the Grignard reagent. Got it? Yes or no?
Yes.
So these are the substrate, and Grignard reagent is the reagent here. Okay. So we have R, which is attacking the carbon atom. Okay. Now let us see what is happening next. Next, we are going to add water. You may also see that there is some H plus here. That means in acidic condition they're adding. But if you just add water, then also it is fine. है ना? दोनों चीज आप लोग को मिल जाएगा. Don't worry about that. Acidic hydrolysis or just hydrolysis. Now, when we have hydrogen here, then hydrogen gets attached to this. What is H2O? H2O is HOH. OH attaches on the Mg. Hydrogen attaches with the oxygen atom, right? Because Mg will be what? Delta positive. This oxygen will be delta negative. This oxygen will be delta negative, and hydrogen here will be delta positive. Okay. So it is all completely electrostatic. That means you have to identify the electron deficient side and the electron rich side. That's it. And then do the reaction. So in the product, what are we going to get? The carbon atom, the 2 bonds as it is, single bond oxygen, and then 1 hydrogen. And there will be an R group attached on the Grignard reagent. All of you got it? Yes or no? Please tell me. Yes or no? Please tell me, guys.
Yes, sir. Got it.
Got it? Now see, number 1, if I have a formaldehyde, please write, if I have formaldehyde. If I have formaldehyde, that means both of these bonds will be with hydrogen. So we'll have carbon atom with a double bond. There will be hydrogens and hydrogen. Hydrogen here and hydrogen. This is formaldehyde. Plus we are using any Grignard reagent. Let us write here CH3MgX. Then first of all, what is going to happen? I will be having carbon. These hydrogens will be as it is. Single bond oxygen. MgX. Let me write MgBr. So it is more specific. MgBr. This is from the Grignard reagent. And what comes from the Grignard reagent? The alkyl group is what? What is the alkyl group here? Tell me. What is the alkyl group here? What is the alkyl group here? Very good. CH3. CH3. Very good. And then further on the addition of H2O on hydrolysis, what happens? This MgBrOH will be, we will be getting that thing, and also we'll be getting CH3. What is this? CH3, CH2OH. CH3, CH2OH. सबको दिख रहा है? I hope yes or no? Plus we'll be getting MgBrOH like this. Okay, so this product is not very much important for us. This alcohol is important. If I see here formaldehyde, then I am getting, it gives primary alcohol. Right, next. Any other aldehyde?
So can we note it down, the Grignard reagent?
Yeah, ये note down कर लीजिए आप. Sorry. Done, guys? Yes or no? Please tell me.
Done, sir.
Okay. So with formaldehyde, it gives primary alcohol. Right, next, other aldehydes. देखिए अभी ना खुद से आप स्टार्ट कर दीजिए सोचना इस बारे में, राइट? We will have carbon double bond O. Now in both of these bond, one of the bond will be with any R group, right? Let me write here CH3 or so. Write R here only, and I will have another will be hydrogen, right? This is an aldehyde. Plus, if I add CH3 MgBr, look at the pattern. What is going to happen? Those bonds are as it is. It doesn't matter what you have on the carbonyl carbon. What you have on the carbonyl carbon, they will be as it is. So this carbon will be having this R group as it is. This hydrogen as it is. This OMgBr will be added, and then the carbon is going to get again a CH3 group here, right? If there was CH3CH2, then it would have got CH3CH2. If it had anything else, if for example if it had a benzene ring attached to MgBr, then it would be getting a benzene ring. That is not changing. Whatever is attached on the Grignard reagent, the hydrocarbon part is getting attached on the carbon atom, and on further hydrolysis, we are going to get this carbon atom. It has a hydrogen and it also has a CH3 group, and it is getting OH. So this is a 2-degree alcohol, right? This is a 2-degree alcohol. That means other aldehyde gives secondary alcohol. Okay, then we'll be looking at ketone. Now, what is ketone? Ketone is nothing but C double bond O as it is, and 2 R group. Let me write R dash, and here let me write R group plus CH3 MgBr. Instead of CH3 MgBr, there can be other things also. So we have carbon R and R dash, and CH3 gets attached here. OMgBr.
Ketones will remains the same.
Sorry.
Like that ketone will remain the same.
Ketone तो same नहीं रहा ना. Ketone में R groups will be same ना. R group तो change कभी नहीं हो रहा ना. See, this is not changing ना. ये तो यहाँ भी change नहीं हुआ था. क्या पूछ रहे हैं आप?
Okay, sir,
Got it? जो चीज यहाँ पे है, the groups that are attached to carbonyl carbon, they are not changing. Okay, there is just an addition of alkyl group from the Grignard reagent. So here I will be getting, see, this R is there, and then this R is having a carbon atom. It is attached with R dash, and then comes CS3 also, OH. So this is a 3-degree alcohol. So ketone gives tertiary alcohols.
Can you once again explain the mechanism
For which one?
for ketones?
For ketones. देखिए,
Yes.
आप बताइएगा, ठीक है? In this ketone, what do you think which is the most reactive part? कौन सा atom is the most reactive? R, carbon या oxygen? Which carbon is the most reactive? R वाला या ये carbon?
It's a carbon.
Carbon. It will have what kind of charge? Delta positive or delta negative?
It's a positive.
Delta positive. Very good. We have identified the reactive site in the substrate, that is my ketone. Now tell me about this Grignard reagent. Where will I have the most reactive carbon? This carbon here, it will have what charge? Delta positive or negative? Tell me.
It will have positive charge.
This CS3, it will have what charge?
So negative.
Could not hear you. Can you please repeat?
So negative.
Negative charge, right? Delta negative. Why delta negative? Tell me.
So because of MgR.
Because of Mg. Mg is a electropositive. That means it is giving electron. So this CS3 will attack on the carbonyl carbon like this. Now, when it is attacking, that means it is coming up with its electron and it is giving electron to this carbon atom. That means it is forming a bond. Whenever an attack happens, that leads to formation of bond. Okay, it leads to formation of bond. Now, this carbon, it is already having 4 bonds. Now this CS3 is trying to make one more bond. Carbon cannot have 5 bonds. It will break the weakest bond here. So this is a sigma bond, this is a sigma bond, and this here it is a pi bond, right? So one of the pi bond will break like this, and so from the double bond the pi bond will break, and you will get O negative. And you are seeing here that if CS3 is coming up with its own electron, that means it is taking the electrons from here. This Mg is already going to get delta positive. So this oxygen is getting negative charge, and the CS3 is removing itself from the Grignard reagent, and that is why Mg gets a positive charge. Okay, and that is why Mg gets attached to oxygen. After the addition of water, it is simple. We have H, OH, hydrogen gets attached to this oxygen, OH gets attached to this Mg. Got it?
Yes, sir. Thank you, sir.
Okay. But see, the more important point here is to know how to write the products. Okay, you should know how to write the products. Done, everyone? Yes or no? Please tell me. You can do some examples now. Yes or no?
Yes, sir. Done, sir.
Fine, great. See, I'm giving you some. I'm writing some questions here. Okay, and I will also write the alcohol here. Number 1. Let us suppose you have CHO here. So this is an aldehyde. Okay, this is an aldehyde. Plus we will be adding here CS3MgBr. Now I will write here. See, there are 2 different. In the first case, you will be seeing that dry ether is given. That means the first reaction is happening in the solvent dry ether. Okay, why dry ether? Because Grignard reagent cannot touch water. Okay, so once this reaction happens, the first step, that means till here the reaction has happened in dry ether. Then in the second step, we are adding H2O. Second step, what we are adding H2O here. Okay, now what is the product going to be? This, all of these carbons will be as it is. आपने 3 कार्बन थे, 3 कार्बन बना दिए. Now you look, what is the carbon that is in the Grignard region? You saw that. Just add that CS3 from the Grignard region here. Let me write it like this. This CS3 is coming from Grignard reagent, and And also, this CH3 is getting attached on the carbon atom. Okay, so the carbon atom which is aldehyde or ketone, and here you will be getting OH. Got it? Second, if you have, let us say something like this, ketone plus CH3 MgBr. The reagents are as it is. There's no change in the reagent. Dry ether and H2O. The first step we are having dry ether as a solvent. The second we are having water. So here also what is going to happen? You will write each and everything as it is. 2 carbon atoms. This oxygen is going to get hydrogen, and this carbonyl carbon is going to get what? A CH3 group from the Grignard reagent. Where is this CH3 coming from? It is coming from the Grignard reagent. आ रहा है सबको नहीं आ रहा? Please tell me, guys. Tell me yes or no. Can all of you see that? Yes or no?
sir.
CH3
Yes.
MgBr. So here also everything will be as it is. Double bond O will convert to OH, and the same carbon atom is going to get, so this is getting converted to OH. This same carbon is going to get CH3 from the Grignard reagent.
Sir, I understood the second and third. The first one I have a doubt.
Tell
Like,
me.
where does the carbon go from CHO? OH is formed, like OH is already there. CH3 is added. And where is the carbon then?
Where is the carbon? You tell me where is the carbon? ये carbon है ना? ये carbon दिखाया नहीं हमने यहाँ पे. carbon है? नहीं है?
It is there. Okay. It's already there.
It is there. No. Bond line structure नहीं सही है क्या आपका? Revise करना है bond line structure. Sahel. You have
No,
some
fine.
confusion? नहीं,
Yeah, I
सही
just
है,
got
पक्का
confused with that.
अच्छा, ठीक है. It is implicit. है ना? क्या कहते हैं इसको? See, the hydrogens are either explicit or implicit. Whenever you have heteroatoms such as oxygen, है ना? Oxygen के पास अगर hydrogen होगा ना, तो उसको दिखाना पड़ेगा. It should be explicit. But if you have carbon atom, then we don't show the carbon atom. Neither we show the carbon atom attached. Neither we show the hydrogen atoms attached to carbon atom in bond line structures. चलिए, write this down. इतना लिखिए. हमने देखिए सब तरह का करा दिया है यहाँ पे. एक और हम करा देते हैं. Fourth one. So this carbon atom will have OH, and it had already one hydrogen, and it will get CH3. This CH3 is coming from the Grignard reagent. I hope you are done. Write a question. How will you prepare following alcohols using suitable Grignard reagent with methanol? Okay, what is this? Methanol. Methanol means this is formaldehyde only. Methanol means formaldehyde. Carbon with 2 hydrogens and double bond O. Okay, so the first molecule that they have given you is you have 3 carbon atoms like this, OH group here, and one more CH3 here. Okay, you can write this as CH3, CH, CH3, CH2OH. Okay, so this is the alcohol here. Right, so how to do this type of problems? It's very easy. Okay, first you have to see and approach the problem in a very good manner. This is my alcohol. That means this they have given already the product to me. They have already given the product to me, and they have given also one of the reactant molecules, right? So they have given me methanol. That means which is carbon with a double bond O, one hydrogen here and the other hydrogen here, and it is going to give me this product, that is CH3 CH CH3 CH2OH CH2OH. Okay, and now I have to use a Grignard reagent RMGBr. So they are asking you what will be the structure of this R group here. Okay, what will be the structure of the Grignard reagent exactly? This is a very general Grignard reagent RMGBr. So they are asking particularly what is the structure of this R group. Now, first of all, you will identify the parts that is already in the methanol and in the alcohol. Okay, in the alcohol. So see, this oxygen is already there. So this oxygen is coming from methanol, right? Yes or no? Please tell me. Oxygen will be coming from the aldehyde. Yes or no? Correct है? अरे हाँ यार जल्दी बोलिए. Yes or no, guys? No. अरे
Yes,
भाई
sir.
क्या हो गया?
Yes, yes, sir.
इतना
Yes.
टाइम क्यों लग रहा? And this 2 hydrogens are there here also. Okay, and this carbon atom is also coming from this methanol only. Okay, now what should be the Grignard reagent? So Grignard reagent will be this molecule. This R group here will be this fragment. So if I will have something like this, CH3 CH, which has a CH3 group, and it is connected to MGBr, plus we do a reaction with methanol, then from the Grignard reagent we are going to get this fragment CH3 CH CH3, and then we are going to get CH2O from the aldehyde, and this hydrogen comes from the water atom that we add in the later stage. So first step is dry ether. Second step we add water. So this hydrogen atom is coming from that water molecule. हाँ correct, वही तो बोला ना, suitable Grignard reagent. समझ में आया नहीं आया सबको प्लीज बताइए. All of you got it? Yes or no? Please tell me. All of you got it? Yes or no? First you have to match it.
Yes,
Okay.
sir.
First you have to match it here. That we have this carbon atom and oxygen from the methanol, and then you have to find out, okay, fine. If this is already there, then this is the part that is coming from the Grignard reagent. Similarly, if you have something like this, okay, so as soon as you have methanol, see, methanol se kaun sa part aa jayega? This part will be from methanol, yes or no? And this rest of the part, it will be from Grignard reagent. Okay, so what are the two molecules that we have to react? MGBr plus dry ether and water. So here we are going to get this fragment from the Grignard reagent. It will form a bond with the carbon atom of methanol, which already has CH2. This oxygen will also get a OH group like this. है ना? चलिए, write this down. Let me know when you're done.
Can you scroll up?
हाँ, sure. Enough?
Yes, yes.
Done guys, it's no please tell me. देख लिया आप लोगों ने? What happened? I can't. No, लिखे लिखे ठीक है. Done guys. Okay, so from here you will remember some important points. The first one is regarding reducing agents. Okay, so there are two reducing agents that you have to remember. One is LiAlH4. It reduces everything, all to OH. Okay, so whether you have aldehyde or you have ketone or you have carboxylic acid or you have ester, all of these things will be reduced to alcohols. Okay, but secondly, if you have NaBH4, these are the only two that you have to remember: NaBH4 or H2 in the presence of nickel, PT, PD, anything. Okay, now in this case, it is only going to reduce only aldehyde or ketones. That's it, nothing else.